September 10th, 2008. On that day, the entire world was holding its breath. Newspaper headlines, breaking news reports, even conversations in the streets, everything revolved around one terrifying idea. Today, the world might end. Scientists were preparing to activate the largest and most complex machine ever built by humankind. Rumors flooded the media, claiming that once this machine was turned on, it would create a black hole, one powerful enough to swallow the entire planet in a matter of seconds. Welcome to the channel. If this is your first time here, don't forget to like the video, subscribe, and activate the notification bell so you don't miss what's coming next. Back then, people were genuinely terrified. Lawsuits were filed in court to stop the project. Some scientists even received death threats. Imagine the level of fear. Yet here we are in 2026. The Earth is still spinning. We're still alive. No black holes have swallowed the planet. So the real question is, was all of that just nonsense? Or is something far more dangerous and far stranger happening right now beneath our feet? Today, we're going underground, 100 meters below the surface on the border between France and Switzerland to enter the Large Hadron Collider, also known as the sleeping monster. We'll discover how scientists managed to trap the conditions of the Big Bang inside a metal tube. We'll uncover the story of the particle that reshaped modern physics, the so-called God particle. And most importantly, could this machine actually open a doorway to other dimensions or parallel worlds? Get ready, because what you're about to hear may completely change how you see the universe. Let's start from the very beginning. Imagine you're driving through a tunnel, but this isn't an ordinary tunnel. It's massive, 27 kilometers long, and it doesn't run in a straight line. It forms a perfect circle underground. This tunnel belongs to CERN, the European Organization for Nuclear Research. And inside it, the greatest race in the universe is taking place. Not between cars, not between jets, but between the smallest building blocks of matter itself, protons. Scientists built enormous magnets and endless metal tubes for one seemingly insane goal: to send a beam of protons from the right, another from the left, and accelerate them until they reach 99.99% the speed of light. Try to imagine that speed. A single proton can loop around this 27-kilometer ring 11,000 times every second. And once they reach that speed, they smash them into each other. A deliberate, violent collision in the quantum world. Why spend billions of dollars to crash particles we can't even see? The answer is simple: to break them. Think of a child holding a locked toy, desperate to know what's inside. The only way to understand it is to break it open. That's exactly what we do with protons. Because the instant they collide, they generate temperatures and energy densities almost identical to those that existed moments after the Big Bang. In other words, inside this machine, we are recreating the birth of the universe. And that's where the miracle happens. Einstein's famous equation, energy equals mass, tells us that matter and energy are two sides of the same coin. When protons collide with unimaginable energy, that energy transforms into matter. New particles appear, then vanish in fractions of a billionth of a second. Among them was a ghost physicists had been hunting since the 1960s, a particle that challenged the greatest minds on Earth, the Higgs Boson, or as the media called it, the God particle. In 1964, a brilliant physicist named Peter Higgs asked a deceptively simple question. Why do things have mass? Why is the electron so light? Why are quarks heavy? And why does light have no mass at all? Higgs proposed that the universe, even empty space itself, is filled with an invisible field, a field like thick honey. As particles move through it, some interact strongly and slow down, gaining mass. Others, like light, pass through untouched and remain massless, traveling at the maximum speed of the universe. This invisible ocean became known as the Higgs field, and its particle, the Higgs boson. For nearly 50 years, it was only a theory, until July 4, 2012. That day, scientists at CERN announced to the world, "We have found it." Peter Higgs was sitting in the audience. Tears streamed down his face as he watched his life's work become reality. This discovery meant something profound. We finally understood why matter exists, why stars, planets, and even our own bodies have mass. Without the Higgs boson, everything in the universe would be pure energy, drifting endlessly through space. But let's return to the terrifying question: is the Large Hadron Collider dangerous? The fears were not entirely imaginary. In theory, quantum collisions could create microscopic black holes. But even if they form, according to Stephen Hawking's theories, they would evaporate instantly through Hawking radiation. And there's something even more reassuring. Earth's atmosphere is bombarded every single day by cosmic rays with energies far greater than anything produced by the LHC. If such collisions could destroy planets, Earth would have vanished billions of years ago. So no, the world is not ending. But that doesn't mean we're out of mysteries. The discovery of the Higgs boson was not the end. It was only the beginning. Scientists made a shocking realization. Everything we can see, stars, galaxies, planets, dust, and even us, accounts for only 5% of the universe. The remaining 95% is made of something unknown: dark matter and dark energy. They shape the cosmos, hold galaxies together, yet we cannot see them, touch them, or fully understand them. Today, the Large Hadron Collider is operating at its highest energy ever, searching for signs of these invisible components. And there's more. Some theories, like string theory, suggest our universe isn't limited to 3 dimensions of space and 1 of time. There may be additional dimensions, curled up, hidden beyond our perception. Scientists look for missing energy after collisions. If energy vanishes without explanation, it could mean it escaped into another dimension. Think about what that implies. This isn't science fiction. This is happening right now. The Large Hadron Collider is humanity's greatest scientific achievement. Proof that a small species on a small planet can dare to question the origins of existence itself. And with every answer we uncover, 1,000 new questions emerge. That is the beauty of science. If you enjoyed this journey, don't forget to like the video and subscribe to the channel. And tell me in the comments, if you had one question you could ask the scientists at CERN, what would it be? Time travel? Parallel universes? I'll see you in the next video and the next story. Goodbye.